Precalc, Chapter 9, Section 5, Parametric Equations. So we're going to look at these things, evaluate sets of parametric equations given values of the parameter. We're going to graph curves for the parametric equations, rewrite parametric into rectangular form, and then find sets of equations. That's what we're looking at. So parametric equations. So it's a plane curve if f and g are continuous functions of t on interval L. The set of ordered pairs f of t, g of t is a plane curve C. So the plane curve C is made up of two functions, f of t and g of t. So like our x value and our y value of our points are made up of these other functions, f of t and g of t. So these two values correspond to a value t. The equations given by x equals f of t and y equals g of t are the parametric equations for C with parameter t. The orientation is just the direction of plotting the curve as t increases. And that's really the importance here. We're looking at not just plotting points, but the order in which you're plotting points that give you the direction. So let me describe that a different way so you have maybe an idea. If I took a football example here and looked at the routes for some football players, good old Bears. So if Devin Hester runs a post, and then so does Johnny Knox, who retired because he got his back broken. And then if you look at their pattern and you think about what's happening here, you may say that, well, gee, they collide right here. They are actually hitting each other. That if you look at just what their routes are, that one's going to come here, one's going to come here, they're going to collide and fall. Why does that not happen? And that's because those patterns are in relation to another variable, which is time. So as time goes by, they may be at different parts. We have the direction. And so Hester may cross first and then Johnny Knox afterwards. And so we take a curve and we relate it to another variable, t, time. And so we can see the order of which points are plotted. It's kind of a way maybe of understanding what's really occurring here. And so if we're going to sketch this, we have x of t and y equals negative 2t. So x equals t and y equals negative 2t. We can sketch that for our t values between negative 2 and 2. So here's our domain or our values for t. So we can plug them in our table. So negative 2, negative 1, 0, 1. And 2. And you can evaluate the function x and y, both of them, for those t values. So we plug these values in for t from both equations. So x equals t, so that one's pretty easy. Whatever t is, x has to be. So there's one. The other one, to find y, plug it into the other equation. So negative 2 times t. So negative 2 times negative 2 is 4. Negative 2 times negative 1 is 2. 0 would be 0. Negative 2 and then negative 4. Then we can plot our x, y values as we typically do. So then negative 2, 4, negative 1, 2, 0, 0, 1, negative 2, and 2, negative 4. And then we can connect those. Here is our curve. But realize we should put arrows on here for the orientation, for the direction we're going. So we have these points in this direction. So the parametric curve not only has us plot this line, but also actually has this gives us a direction. So graph using a calculator, we can actually take these, and I'm not going to do them on the screen here, but we can take these functions and we can plug them in separately as parametric. So we have to plug in two equations. To do that, you need to go to mode on the calculator and then set it to parametric. Parametric mode, within when you go to your y equals, you would actually have to plug in two different equations. X equals and y equals to plug for both of them. And we do it also for this one for secant tangent and then graph it. So you can give that a try at home. Eliminating the parameter is just to go back into what's called rectangular form, the typical equation, just x and y that we've seen. So we can eliminate the parameter by substituting t in. And so we can take the equation here, x equals 1/4 t, and solve it for t first. So then t would equal 4x. Multiply both sides with 4. Then we can take that and put it in for t in the other equation. So y equals 2 times 4x, the quantity squared. So y equals 2 times 16x squared. So y equals 32x squared. And then that would be the rectangular form for this parametric equation. If we wanted to sketch the curve from the parametric form, we could have t values and then plug in some different t values, -2, -1, 0, 1, 2, and then plug those in to find our x and y equations. If we did earlier, our x is 1/4, so here would be -1/2, -1/4, 0, 1/4, 1/2. And our y values would be squaring and timesing 2. So this would be 4 times 2, 8. 2, 0, 2, 8. And then you can plot those points. So -1/2, 8, -1/4, 2, 0, 0. So you can see how steep, how quickly this parabola would increase, which makes sense with having this coefficient of 32 here. And so you can graph it in the parametric form. You can also graph it in the quadratic form. Either way would work. It would be the same graph. We could put direction on that too. I should have my arrow going this way, so my arrows will go around, and this would be the orientation or direction of that parametric curve. Sketch by eliminating the parameter. So this one's a little different here. If you want to eliminate this parameter, our parameter here is our theta value, but we have to have some relation between these. And so to help me out, we should recall that cosine squared theta plus sine squared theta equals 1. That's always true. So if I can isolate both of these, cosine theta and sine theta, I can plug them into this. So in this first equation, if I divide both sides by 2, I have x over 2 equals cosine theta. For this one here, I divide by 2, y over 2 equals sine theta. So then where it says cosine theta squared, I can plug in x over 2 and then square it. Do the same thing for my sine squared, y over 2 and then square it. And then I can simplify this and write it as x squared over 4 plus y squared over 4 equals 1. And we should recognize this. It is a conic. What conic is it? If you look at our coefficients, 1/4 and 1/4, it ends up being a circle. If I multiply both sides by 4, I find x squared plus y squared equals 4, which would help me sketch it to see that my center is 0, 0, and my radius is 2. Then I can draw my circle and then realize that the orientation is in this direction. You can check that with the parametric form. So find the parameter equation to represent y equals 4x minus 3 using if t equals x. So this was the second equation. We can write out the parametric form. This is rectangular. Y equals y and x is rectangular. And all you have to do is substitute in t for x in that equation. So if I substitute t in for x because they're equal, I get y equals 4t minus 3. That would be the parametric equation. For the other one here, now it's not as simple. It's not just t equals x, it's t equals 2 minus x. So I first need to simplify or solve for x. So this would be adding x to both sides and then minusing t. I get that equation. So I can substitute that quantity in for x. So y equals 4 times 2 minus t minus 3. So we have 8 minus 4t minus 3. Or 5 minus 4t. This would be the parametric form for y, and then we still have our x equals 2 minus t. So those would be the parametric equations for that second example given t. So that's it for parametric equations. Just realizing that you're graphing a curve, but you're graphing in relation to a third variable called the parameter, which gives us an idea of like time is typically when it's used, and orientation, the order in which the points are plotted. Have a good night.